Okay, I'm going to talk about some research work we do at IIAI. So let me first start with a video we prepared for ECCV. ECCV is a top conference in computer vision, which was held last year in Munich, in Germany.
The Inception Institute of Artificial Intelligence is an international research organization based in the UAE. Since its launch in early 2018, we have attracted many exceptionally talented researchers from top universities all around the world, including Oxford, Cambridge, and ETH in Europe, MIT, Stanford, and UCLA in the US, and ANU, Tsinghua, and PKU in Asia-Pacific countries. We aim for both fundamental and applied AI research. For fundamental research, we try to solve challenging problems in machine learning and AI in general. The current wave of AI is mainly driven by deep learning, which usually requires powerful GPU machines and massive scale labeled training data. At IIAI, we would like to design more efficient and intelligent learning models, such as unsupervised or self-supervised learning, few-shot or zero-shot learning, and lifelong learning. Besides fundamental research, our areas of interest in applied research include AI for healthcare, video understanding, and remote sensing. In the healthcare domain, we are interested in both medical images and electronic health records for early detection and diagnosis of various diseases. One example is diabetic retinopathy, a complication of type 1 or type 2 diabetes, which is a major disease in the UAE and other Middle East countries. Another disease we are interested in is breast cancer, for which we rely on digital mammography for early detection. For video understanding, areas of focus include face recognition, person and vehicle re-identification, human activity recognition, and behavior analysis. In the field of remote sensing, we apply advanced learning techniques to enhance the quality, detect salient objects, and analyze the changes in images obtained by either satellites or UAVs.
We are putting all our efforts to build a bridge to ensure the transfer of knowledge from fundamental research and apply it to solve real-world problems. Our engineers use the most advanced technologies and work closely with our researchers to apply the new deep learning techniques. As engineers, our role is to ensure the scalability of all these algorithms. We develop tools and dashboards for data exploration, understanding, and visualization. Here we have our data center. We have a strong technological capacity for operating. So here we have our DGX-1 machine. We have more than 200 DGX-1. We already pre-ordered more than 100 DGX-2. It's like more than 5,000 GPU. For our HPC computation, we have our servers, more than 31,000 CPU cores. We have more than 140 terabytes of RAM memory, more than 25 petabytes of storage in both SSD and HDD. It's absolutely huge capacity for technology. I'm sure that in the world, not a lot of companies have this strong capacity for operating.
Our office is located in the central business area of Abu Dhabi on a beautiful Al Maraya Island. Abu Dhabi Global Market Square is within the walking distance of shopping malls, various restaurants, the Cleveland Clinic that offers the world's best healthcare, and multiple Seaview luxury residential blocks. Being the home to 175 nationalities, the UAE provides an open-minded and hospitable living and working environment to all expats. From clothes to cuisines, in the UAE you can always find the humblest and the most extravagant. Our people's ideas are changing the world, and our culture is built on flexibility, collaboration, and innovation. At IAAI, you can be inspired and be inspiring at the same time. In fact, we enable our people to play to their strengths. We offer an open door policy that will open doors for you and your career.
Okay, so that's like an overview of III. Some of the information actually is outdated, but at least to give you some overview. So we have access to 3 types of resources. First, the AI talent. So as I mentioned, actually, we have attracted over 100 researchers from around the world now, from all the top universities and companies. So I'd like to especially mention the 3 people on the top. So the first one is called Professor Sir Michael Brady, who is my PhD supervisor at Oxford. Actually, he is considered one of the founding fathers of computer vision and image analysis. He's a fellow of the Royal Society and the Royal Academy of Engineering. He has actually educated and cultivated many famous researchers nowadays. One of them is called Andrew Blake, who used to be the managing director of Microsoft Research in Cambridge, and now is the head of Samsung Research in Cambridge. Another one is called Andrew Zisserman, who is actually considered the top 1 researcher in computer vision. He is a 3-time Ma Prize winner. Ma Prize is the best prize in computer vision. And the second one is Professor Andrew Yao. He is a Turing Award winner. So actually, he is the only Turing Award winner in Asia. He's now a professor at Tsinghua University, and also he started an institute called the Turing Institute of Artificial Intelligence in Nanjing. So he's very famous in China. The third one is called Professor Anil Jain, who is the most highly cited researcher in several areas, including computer vision, pattern recognition, image processing, and biometrics, and also a top 3 most highly cited researcher in machine learning. The fourth one is Professor Tianyu Tan. He's probably the most powerful AI person in China. He's a high official now based in Hong Kong. It is very likely he will be the Minister of Science and Technology of China in the future. So these people are our actually scientific advisory committee members. So they will come to visit us once a year. Some people will visit more frequently, so they will give us direction and advice about research ideas, etc. So they will help us to develop our institute. So besides talent, we have really powerful computing facilities. So as I mentioned in the video, we have actually over 600 DGX class servers. So one DGX1 has like 8 V100 GPU, NVIDIA GPUs. DGX2 has 16 V100 GPUs. So it's nearly like 10,000 DGX GPUs, V100 GPUs. So and also we have a lot of like CPU servers and the memory storage. So this is very useful for AI research, because nowadays it's the deep learning era. For everything is based on big data, and we need really powerful GPU machines for training the models. And we also have access to various massive data. So, for example, medical images and other healthcare data, public safety data like surveillance camera data, financial records, and also satellite images. So all these 3 components will contribute to the research in AI. These are our resources. So as I mentioned, our institute was founded actually early last year. So it's been just over 1 year now, but we have made some achievements so far. So we publish a lot. We have already published over 50 top conference papers and over 20 top journal papers. For example, just a few weeks ago, we received a notification of CVPR submissions. CVPR is the top 3, actually the top 1 conference in computer vision and pattern recognition. So we have 25 papers accepted by CVPR this year. This is like a record among all the organizations in the world. So actually, I recently visited the University of Amsterdam. So UVA has multiple groups working on computer vision. So the whole university only has 6 papers accepted. Actually, the president of the University of Amsterdam told me the whole Netherlands wouldn't have over 20 papers. So 25 papers is like a record for any organization. So we also file a lot of patent applications. Of course, we only file those patents which are worth protecting. And we're also involved in a lot of conference organizations, etc. So I was the general chair of BMVC last year. BMVC is a British Machine Conference, which is the number 4 conference in computer vision. We also organize workshops with top conferences like ECCV and BMVC. We also sponsor quite some top conferences, like last year we sponsored ICML, ECCV, and NIPS. And this year we're going to sponsor ICCV, CVPR, and probably NIPS. So we also have some collaborating programs. For example, we host visiting professors and visiting students. Currently we have over 30 students. They are like interns, both like masters and PhD students working with us. They also contribute to the publications. We're also establishing some joint labs with famous universities in the world. For example, as I mentioned, the University of Amsterdam, we have just signed a contract with them. So this joint lab will have over 10 PhD students and 1 assistant professor and maybe several postdocs. We're also working with the University of Edinburgh, New York University, Tsinghua University, which is the best university in China, Shanghai Jiao Tong University, which is also a really good university in China, and several other universities. So let's talk a bit about research. So as I mentioned, now it's the deep learning era. So deep learning has been really successful in the previous few years. So it has made a lot of achievements in different areas, like image recognition, speech recognition, NLP, different areas, healthcare. But deep learning is not perfect. Deep learning has some shortcomings. Firstly, deep learning requires a lot of training data, and the data has to be annotated. So it's mostly supervised learning, and it requires really powerful machines to train the models. And deep learning usually considers like a black box, so you do not know what's going on inside the box. But for certain areas such as healthcare, so the doctors would really like to understand how the model works. So that's why deep learning is not a solution for true AI, not to mention AGI, artificial general intelligence. So we actually target to, we aim to tackle AGI, artificial intelligence. So that's our long-term goal, but it's maybe to be like 20 or 25 years. So it's really a long-term research target. So at IIL, we work on different areas. We try to solve challenging problems in machine learning and other areas of AI. So this kind of lists a few examples of different learning scenarios. So supervised learning, for each training sample, we have annotation. So every sample is annotated. That's fully supervised learning. Semi-supervised, some of the data are annotated and most of the data are unannotated. So that's called semi-supervised learning. For unsupervised learning, all the data does not have an annotation. So we try to learn the structure and the clusters among the data. The zero-shot learning is even more challenging because we try to recognize unseen classes which are not included in the training data. So these are some of the areas we're working on. This is more about fundamental research. So besides fundamental research, we also work on applied research. I'm just going to quickly go through some of the use cases we are working on. The first one is about the transportation. So it's the detection and the annotation of vehicles. So we can detect annotated attributes of all the vehicles. It's based on a deep learning network. I have a short demo here. Let's have a look. So this is in a city in the UK, it's Newcastle, one of the roads in Newcastle. So you can see every vehicle has been localized and annotated with the attributes like the pose, make, brand, color, etc. So different scenarios. So this clutter is more challenging. Of course, we can more broadly, we can do video monitoring. So it's monitoring different objects like the pedestrians, vehicles, and other popular objects. And if we can associate this with other information like the GPS information, then we can potentially track each object, like each pedestrian or each vehicle in a city. So this use case is about 2D to 3D conversion. So the input is one 2D image, and the output is the 3D shape of the image. So this is just for objects. So it's very challenging. It's based on GAN, so Generative Adversarial Network, so which is the combination of generator and a discriminator. So this is 2D, 3D conversion for scenes. So it's more complex than just objects, because we have to also reconstruct the layout and the relationship among the objects and also the background information. So it's more challenging, but it's also based on a variation of GAN. This is about healthcare. So it's a DR, diabetic retinopathy detection. Actually, DR is a complication of diabetes, which is a major disease here in this region. So we actually performing the best in the world. So Google used to be the best. Now our model performance is even better than Google. So we're collaborating with some hospitals in Abu Dhabi, like Cleveland, for making this into a product. So another healthcare use case, breast cancer based on digital mammography. So this is quite challenging because usually we do not have a lot of training data for abnormal cases. So that's why it's, this model is patch-based. So we learn a deep learning model based on each patch, and afterwards we concatenate the output of the patches into the final decision making for the breast cancer. So we can classify the images into normal, abnormal, benign, or malignant of the cancer. Another one is about breast brain image analysis. It's similar as the breast cancer one. It's also patch-based because we can do segmentation and classification of the different tumors and diseases based on imaging. So object detection is a popular area in computer vision. So there are some generic techniques. You can see all the methods proposed in the years. We have some top experts in this area working on detection. I'm going to show you two of our demos. So the left one actually is more for both detection and segmentation. So it can be used for self-driving cars and other video understanding scenarios. The right one is for a specific object called drones. So you can see the drones can be detected in different conditions and scenarios. We also work on satellite imagery analysis with different applications, for example, image classification, super resolution, and also object detection. For super resolution, it's quite useful here because usually the image quality, the resolution of the satellite images are not high enough. So we use super resolution to boost the resolution and the image quality. You can see the bottom left, this input patch is in low resolution and it's quite blurred. After super resolution, you can see a lot of details. And detection after the objects, different objects are detected, we can do change detection to see what has been, what's going on in one region. Some examples, you can see the objects, some planes and other objects have been detected, and after applying super resolution, the image quality has been boosted. So another example is about video understanding, so it's action recognition. For action recognition, if we want to use deep learning, it's quite challenging because we have to annotate a lot of video samples, and it is tedious and time-consuming because for each video sample, we have to annotate the class, the attributes. Each one has like 64 attributes. So it's really time consuming. That's why we have used a technique to simulate the training data. We use computer graphics to generate the human actions with different backgrounds, different body types, gender, and scenarios and viewpoints. So you can see they look quite realistic, and then we can augment the simulated data with some real data for training the deep learning models. Some of the results for action detection and attributes prediction. So all the yellow boxes are the correct localized actions, and the blue ones are the correctly labeled the attributes. You can see some of them are really challenging. Like this one, it's a biking action, and it's really blurred and it's very small. And this one, cliff diving, walking with a dog, these are all the challenging cases. And some of the other more challenging cases, so the red box is actually the wrongly detected actions, but actually they look quite similar to the ground truth. And that's it. Thank you.